All right, y'all. So I'm coming back with some of the problems. So we're going to solve LeetCode problem 605, can place flowers. Basically, you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. That means so the key word there is adjacent. So basically, we want to take a few notes like always. We want to take our time here. Use the umpire method or whatever method you use to. I'll do the UPI method, right? Because umpire, when you start figuring out like what type of programming or what type of patterns that you have recognized before, but since we're all still learning at the beginning, we're just gonna do the UPI, right? Understand, plan, and implement. So we're gonna see what's the input, right? So the input is array represented um, representing a flower bed, right? So that's what we want to do. And then it says, given the integer array of flower bed containing zeros and ones, where zero means empty and one means not empty. So, zero means empty. I don't have to put one because we kind of already understand that, right? And then I like to put output here. All right. It says, yeah, an integer n return true if n new flowers can be planted in a flower bed without violating the no adjacent flowers rule and false otherwise. So basically, adjacent. I hope I'm spelling that right. Yeah, adjacent means no flower planet to the left or right. Right. So that's basically what it's saying, right? And so the number is n equals can these be planted? Right. We're gonna get a little hood with it. Can these flowers be planted? Right. And so the output is either true if n can be planted and false if not. Cool. Constraints. Now, when you think about this problem, it seems kind of straightforward, right? Because when you say 0, 0, 0, 1, right? And say for instance, n is equal to 1, we know we can plant a flower here because adjacent, I don't have one planted here, I don't have one planted there. The problem that we'll run into is if we get an array flower bed that's like this, right? If we get a flower bed that's like this, right? And say for instance, n is equal to 2. N is equal to 2, right? So we know by observation, right? We know by observation we can plant one here, and we know we can plant one here. The problem is how are we going to represent that in the problem, right? And then edge cases. I mean, that's really the edge case, right? Let me erase this. So edge case account for numbers on the end. We know one, array of one, it returns false, right? So that's the edge case. Edge case that's gonna take care of itself. So what we're gonna do is we're gonna plan, right? Because we want to plan. We're gonna set up a count variable um to see how many we can plant, right? Or I can use in, and basically every time we plant, so every time we plant, I can basically subtract it from n, right? So basically, every time we plant, and if n is less than zero in our return statement, that means we are able to plant, so we'll return true there, right? So cool. Um, we want to. I should have did this different. We want to account for the um edge cases on the end of the array. All right. And then implementation, I mean, I kind of spelled it out there, but implementation, you'll just, create count, I just keep it short, count variable, and then we will loop through um, flower bed and basically plant where conditions are met. So it sort of reminds me, just when I think about it, of like a greedy algorithm, right? Um, so what we're gonna do is exactly that, right? So we got what we need up here. Um, I'll just do this so we can see, right? We can always look at the plan. I think that's the most important thing. So we're gonna create our count variable here, and we're gonna initialize that to 0. And then step 2 says we're gonna loop. So for I, so this is a trick I like to do. Instead of like always having to do range, lens, and all of that, I like to do so flower bed, the length of flower bed. I'm thinking about JavaScript because as you can see at the top of my screen, I'm doing some advanced JavaScript stuff. So the length of flower bed, right, is length. All right. So for I in range of length, right? So for I in range of length, we're gonna say if flower bed, right? Flower bed I um equals 0, right? So we're initializing like we want, as long as it equals 0, now we can check on all these parameters, so left and right and all that. So since we have to account for the edge case, right? Um, so we'll say previous space equals, um, so the previous space if I equals 0, right? So this is the first spot. So our index, the first element in the flower bed is gonna be I equals 0, right? And then we could say previous space again is if we have one on the end that equals 0, right? So we'll do, I think it's flower bed I minus 1 equals 0, right? So that's going to account for the one behind, so previous. So this variable is going to account for the first element, or it's like a trick. So it's taking care of the first element if it's 0, and also if we in the middle somewhere, it's going to check the left for us. So we're going to do the same thing for the right, right? So we'll say next space, right? And we'll say equals I equals length minus 1. So we're taking care of that end spot, right? So if I um equals length minus 1, it's that last spot that we pointed to down here. So this that spot, it's accounting for this right here. All right. And then we're gonna say or, so we're just gonna do the exact opposite. So next space means flower bed um 1, I mean plus 1. I'm trying to do this with, I'm practicing on my typing too, y'all. I can type good, but when you talking about symbols, I'm trying to get better. All right. All right. Cool. So, all right, let's just look down. All right. So we're accounting for all spaces, right? With previous space, we're accounting for the first spot in the array if it's a zero. And then we're counting for anything in the middle if left is clear. So the space behind us isn't clear. And then next place, I am counting for the last element and then the next one onto the right. So it's basically taking care of like if it was previous to the flower bed, it's a zero there and one after two, right? In hindsight, it's hard, maybe hard for you to understand. So we're gonna say if previous space means Boolean, right? Like we want to make sure that this is something, and then we'll say or next space, we're gonna say flower bed I is gonna equal one, right? That means we're planning a one there. And then guess what we're doing with count? We're doing count plus or equals one, right? So in our return statement, so I can say I basically, if I want to do, I can say if count is more than or equal to n, then I can return true. Else, return false, right? So basically, it's saying if I was able to plant, if my count is more than n, that means I was able to plant all of n. That way, I'm not like limiting myself to stopping the function at n. I'm going past it because this is an easier implementation, right? But what's even better about this is I can just say return count equal to n. And as you know, when we say this, it automatically turns it into a Boolean. So let's run this. Hold on, it's something that I do, right? Oh yeah. Oh, they tell you what. Yeah. All right. Something that I'm missing here. Let's see. I think it's here. Is it and here? Let's see, y'all. Mm-mm. It's something I'm missing here. Let's see. This space, five bit. Previous space. Is this? Is that? Next space for I in range count. Count. So this one was false. So that means it looked at this for a reason. So let's see. Uh, these are definitely or. Seem like this is and because it's accounting for both. Oh, all right, y'all. All right, so I have also code path here. Let's start a new session. Let's clear this. Oh, that's what it is. I am tripping. Yeah. Okay. Right. So thank goodness for Code Path. We got that to help you figure out the problem. It doesn't give you answers, but it gives you hints. So let's test this. All right, we solved the problem. It beats 48.93%, so not too bad. But it's good to be able to understand these problems from the mental, the mental side of things, and not remembering syntax. Is understanding why things happen. And I think that's one thing I have gained over the past few months with practicing with algorithms and things of that nature, is being able to challenge myself to not remember syntax, but to focus on the concepts, right? Just like I had a problem earlier, you probably have seen it. It's called um, adding two numbers or something like that on LeetCode, where you had to use nodes in a linked list, and understanding self dot value and how to set it up, and then also how to set up ternary, and that way to set up variables and things of that nature. So being able to just kind of understand, and I think once you start with you start with strings and arrays, and you get good at those, and then you move on to like linked lists, and then you link lists, and you go to binary trees, and then you go to binary trees, you go to graphs, you can go to graphs, and uh, things of that nature. I think going in order and really understanding, each data structure, and then you can, in the meantime, you'll develop habits and start to understand like algorithms, right? Breadth first search, depth first search, where you go all the way to the left until you can't no more, and you traverse back up. And breadth first search is when you go left, then right, then left, then right, then right, then right. Understanding those concepts, I think, will help you not only. So some people always say like, I don't see where, algorithms help you out on a job. No, it helps you out because when you start to look at like code and you start to read code, especially with AI being a thing now, being able to read code and being able to understand algorithms, it helps you like, oh, okay, this is where the code is probably putting out, faults or whatever. Let me go in this code and then go line by line, destructuring it and making sure I'm writing tests, as I build onto my code base. So this helps a lot. But anyway, this video is way longer than some of y'all are gonna watch, but I appreciate y'all for watching. Enjoy your night. Let me stop it here.